Hey, this is Dan the Man Martin, bringing you a bonus video for DTM Chemistry. And today we are going to be talking about mixed unit conversions and English to metric or metric to English conversions. And these are so much fun. I hope you'll enjoy them as much as I do. And so to start us off here, I went ahead and put some English to metric conversions down to help guide us in our problem sets. And you'll notice that we have conversions here for weight and length and volumes. And so we'll be using some of those to work our problems. And let's just do it by example problem. That's usually the best way to go about these things. And the first example problem we have is how many kilometers are in 65.6 miles. And so I always say, you know, I had some friends that lived in England, and I was describing the distance between Nashville, Tennessee, and Bowling Green, Kentucky, where I live, and they would always ask me, well, how many, you know, I say it's 65, almost 66 miles, and they say, well, how many kilometers is that, or kilometers is that? And so I would have to pin it out. And as with all these conversions, the first thing you need to do is underline what you're solving for. So you are solving for kilometers and write down what you're given, which is 65.6 miles. All right, and so the thing to do is to always get your English unit into a metric unit as quickly as you can. And so if I look over here in my conversion chart, I want to see if I can find miles somewhere, and I'm scanning down here and I see miles here to meters. Okay, well, that you might think, well, that's not going to help us because it's asking for kilometers. But once you get it into a metric unit, you can go from kilometers or meters to kilometers. So let's do what we can do and see if we can get there. So as with all the conversions, you'll write a conversion factor, and whatever you're given will go on the bottom. We have miles to go on the bottom, and it tells us 1 mile is equal to 1,609.3 meters. Okay, so if we stop there, we would be at meters, but we need to go to kilometers. And so we're going to have another conversion factor here. And so meters will go on the bottom and kilometers will go on top. All right. So now we are back at one of the first units of our chemistry class, and we need to convert kilometers to meters. So we'll have our handy saying, kids have died over doing conversions metric, right? So here's our prefix chart. We'll notice that we have kilometers here on top. And in the middle, we have our base units, meters, liters, seconds, grams, and so forth. And so if we count down from kilometers to meters, we have 1, 2, 3 steps, right? You don't count where you start, but you count where you're going. So kilometers is bigger because it's on top, and you have 3 factors of 10 or 1,000 meters per kilometer. All right. And so now you multiply across the top and divide by the bottom. So it'd be 65.6 times 1,609.3 times 1, all that divided by 1,000. And I worked it out for us to save us a little bit of time here. So when I work that out, I have 106 kilometers. I rounded it to 3 significant figures. We'll pretend like all these in here are exact and have an infinite number, so we'll just use what we start off with there. Notice here that miles will cancel, right? Meters will cancel, and our final answer will be in kilometers. Okay, very good. So let's do another one live because they're so much fun. And so let's do our kilograms to tons. So here we're solving for tons, and we have 8,500.8 kilograms. And we know we're going to have to get kilograms to something else before we can get it into tons. And so if we look over at our conversion factors here, what can we change it to? What English unit can we change it to? So scanning through here, looking for kilograms kilograms to pounds. All right, so very good. So let's change it to pounds. So we say 1 kilogram is equal to 2.204 pounds. Okay, and then we need to look for pounds, and we need to look for tons, or something we can get into tons. And the first one here is 2,000 pounds is equal to 1 ton. So that will be an easy one to do. So pounds will go on the bottom, right? So 2,000 of those will go into 1 ton. Kilograms will cancel, pounds will cancel, and then we got tons, T-O-N-S, right? Tons. And let's see, what did I get there? I got 9.368. 9.368 tons. Here we have 1, 2, 3, 4, 5, 1, 2, 3, 4. So I should actually have one more sig fig here, and I think that was 7 point something. We'll just say, to save ourselves, 7.6 tons. If you work it out in your calculator, you get something else. That's fine. I just want to have the right number of significant figures there. All right. So now we have a, that one was one of weight. We did distance, and now we did weight. And now we're going to do volume, right? Because we have 500 gallons. And we're going to have to change it to kiloliters. So gallons, we're going to have to change to some metric unit. And let's see what we've got over here that we can do that. We've got gallons to quarts, right? That's not going to help us because those are both English units, but we got gallons to liters, right? And so since our objective is to get it into a metric unit right away, let's do that one. So we say that 1 gallon is equal to 3.785 liters, all right? So that's not going to get us there. We got to go to kiloliters, so we need to figure out how many liters are in a kiloliter. Kiloliters are bigger because they're on the top of our conversion factor, and then we're going down here to a base unit again because we've got liters here. So we've got 1, 2, 3 steps down, and so there's 1,000 liters per kiloliter. All right. So now we're going to multiply across the top and divide by the bottom. So 500 times 3.785 divided by 1,000. And I think I did that. I get 1.893 liters. Let's write down here next to my beautiful mug. 893 kiloliters. I put kilograms there. Silly me. It's kiloliters. And that is the conversion. So 500 gallons is equal to almost 2 kiloliters. So I think on the next one we're going to do some mixed unit conversions. So let's go ahead and get started on those. Those are so much fun. You will love those. Okay, so mixed unit conversions. And these are kind of like if you have two different types of measurements that go together, and then the ones that we're going to do are distance and time type conversions. So we've got 60 miles per hour. We've got a train traveling that fast, and we want to know how many meters per second that it's traveling. So let's do that. So you got 60 miles per hour. I always like to write them on top of each other like that, and you'll see why here in a minute. And then we've got to go to meters per second. Okay, so that's what we're solving for. Let's underline that so we don't lose our way. And so on this one, how do you eat an elephant? Well, you shouldn't eat an elephant because they're an endangered species. But what if you were to eat something that's a whole bunch? Okay, so you eat it one bite at a time, and that's how you do these problems. You have to solve for the miles first, and then you solve for the time component on the bottom second. So we're going to change the miles to meters first. So we'll put miles on the bottom so it'll cancel out. And then we got to find something that we can convert miles to. Can we go from miles directly to meters? And as it turns out, we can, because we have that conversion. 1 mile is equal to 1,609.3 meters. Okay, so that's going to be easy, right? So 1 mile is equal to 1,609.3 meters. So we got the top part solved for, and now we've just got to go from hours to seconds, and that sounds like that's pretty reasonable to do. But there's one thing that you've got to keep in mind when you're doing this. The miles will cancel because it's on top, but the hours here will have to go on the top of the conversion instead of the bottom. Since it's on the bottom, it has to go on the top to get it to cancel out right. So 1 hour is equal to 60 minutes. Famous TV show, right? And then the hours will cancel out, and so we're left with minutes. So minutes will go on top again, or I guess I should say the time fraction will go on top again. Since it's on the bottom, it goes on the top. 1 minute is equal to 60 seconds. All right, and so now we set up our problem. So here it'll be 60 times 1609, 60 times 1609.3, all that divided by 60 times 60. And that will give us our answer. Notice here the minutes will cancel out, and we'll end up with seconds on the bottom and meters on the top, or meters per second for our answer. And let's see what I got for that. I got 26.8. So train really getting it, right? 26.8 meters per second. If you were standing out by the railroad tracks, that would almost make your head spin as fast as it's going. All right. So in the next problem, we've got a cheetah. This is when I worked this out, I thought, man, oh man, that is got to be wrong because it is so incredibly fast. I double checked myself and my math was right. So you got a cheetah, and the cheetah is running 120 kilometers per hour. Okay, and the question is, how many feet per second is that cheetah going? And this one's a longer problem, so I'm going to erase this and put our starting point back over in this direction a little bit, because we're going to have multiple conversions here to write down. So kilometers per hour, and again we're going to solve for the top part first. So kilometers will go on the bottom, and we've got to get that to some sort of non-metric unit, and I don't think that we can do that quite yet. I don't see meters. You know, you could go to yards, and I didn't have the maybe I don't have the conversion for yards to the feet, so we're going to go from yards to centimeters, and then we're going to go from centimeters to inches, and then inches to feet. We might have been able to do a little quicker another way, but it'll work this way. So 1 kilometer is equal to 100,000 centimeters. So if you go, kids have died over doing conversions, metric. You've got centimeters here, and you've got kilometers way up here So kilometers bigger, so it'll receive a value of 1. You count down and you got 1, 2, 3, 4, 5 steps down. So 1, 2, 3, 4, 5. Here zeros are factors of 10. So we got to centimeters, and we can go from centimeters to inches, and then finally inches to feet, right? So here you get 12 inches is equal to a foot, of course. 2.54 centimeters is equal to 1 inch. And then we've got the feet part of our equation taken care of. Here again, hours will go on top because hours are on the bottom of our conversion factor. So 1 hour is equal to 60 minutes. And then 60 minutes, 1 minute is equal to 60 seconds, I should say. Okay. So you got a lot of things to plug into your calculator. 120 times 100,000. Divide all that by 2.54 times 12 times 60 times 60. If you do that, you get 27 feet per second. Wow. That is booking. That is really going really fast. And so you could also do a little problem and compare that to the meters per second that the train was traveling. And I'd encourage you to do that. It's a very similar problem, a little bit easier because you can go from kilometers to meters a lot faster, a lot easier. Let's do that up here. Let's just do that. So you got 120 kilometers per hour, right? And so if you were to convert that to meters per second, like we did up on top here, you got kilometers here on the bottom and meters. So you got 1,000 meters per kilometer. And then you got, for every 1 hour, you got 60 times 60. We'll just do that down here. Make it a little bit quicker. Would give us our seconds per hour. And when I did that, I got 33 meters per second. Okay, so let's compare that to the train. It's actually going faster than the train. I read when I was doing the research to find out the speed of the cheetah. As it turns out, the cheetah can run faster than the train, but only for about a quarter mile before it tuckers out. And so if the train was going 60 miles per hour, the cheetah could beat it, could run faster than the train for about a quarter mile, and then he would give up, or she would give up. So I thought that was pretty fun. All right, so these are fun problems to work, and I'd encourage you to find some practice problems to do these with and have a good time with them. So that's it for this bonus presentation. I think hope you enjoyed that as much as I did. Thanks a bunch.